Have you ever wondered why, in the same cosmic space, electrons are being constantly pulled and pushed, flying around as if they're bouncing off walls, while neutrinos pass through this space almost as though it doesn't exist at all? It's like a strange paradox where different particles seem to experience the universe in drastically different ways. To simplify this concept, imagine that the entire universe is one large map, but each particle is like a different model of radio. Each model of radio can only pick up a specific set of channels, and those channels are different for each particle. However, this channel that different particles tune into isn't some mystical or abstract idea. In the framework of the energy filament theory, this phenomenon has a very real and specific counterpart. It's linked directly to the near-field texture that each particle carries with it. You can think of this texture as a microscopic, finely detailed surface or set of teeth that surrounds each particle. The specific kind of texture it has will dictate how well it can mesh or interact with particular textures in the surrounding energy sea. This interaction defines the channels or frequencies the particles can tune into. For example, electrons have a highly adaptable texture that is perfectly suited for interacting with the electromagnetic textures present in the energy sea. This means that electrons are essentially tuned in to the electromagnetic field, and they are highly sensitive to any changes in this field. If the surrounding energy sea begins to show slight signs of aligning with the electromagnetic texture, the electrons will immediately lock into that alignment, altering its movement and rhythm. This makes electrons incredibly responsive to electromagnetic fields. In contrast, quarks and protons have even more intricate textures. Their near-field textures primarily interact with the color texture network, which is associated with the strong nuclear forces. As a result, quarks and protons tend to first experience and react to the short-range, intense colored fields inside atomic nuclei. Protons, in particular, are a little more complex because their near-field texture needs to simultaneously interact with a variety of fields. In addition to color texture, protons must also engage with the electromagnetic texture and the tension gradient, which means they are essentially listening to multiple channels at once. However, just like tuning into multiple radio stations, each channel is received at a different volume, meaning the proton's sensitivity to each of these fields can vary significantly. Now, let's talk about neutrinos. Neutrinos are particles with a very different set of characteristics. Their near-field texture is extremely simple and minimally sensitive. Compared to electrons or protons, neutrinos do not resonate with the electromagnetic or colored textures in the energy sea. Their texture is almost imperceptible to these channels, meaning they don't interact much with them at all. The only field they respond to is the tension field, and even then, their response is very weak. Neutrinos essentially glide through space with minimal deflection, only slightly changing direction when they encounter areas of higher tension. This explains why neutrinos can pass through thick layers of matter almost unaffected, while other particles like electrons are dramatically altered by their surroundings. So what's the takeaway from all of this? Each particle comes with its own near-field texture, and this texture dictates its channel list, the fields that are significant and the ones that are just background noise to it. This means that different particles see the universe in vastly different ways. Some fields, like the electromagnetic field, may be the main channel for some particles, while for others, those same fields are just noise. This concept, when understood in the context of the energy filament theory, provides a fascinating new way of thinking about the fundamental interactions that govern the universe. Tap follow, share it on New Physics, Clear Universe.